Good morning. I am Professor Mohan, Department of Civil Engineering, continuing a lecture, Structure of Expansive Soil, Bce078. So this is my second lecture in Unit 2. And this lecture covers some aspects like field explorations, soil testing. The field explorations you know about the soil. The soil has a special character. Normally, we say the swelling potential. We are dealing with the foundation on expansive soil, so swelling potential is a special character of such soils. The swelling potential is those which excessive swelling clay minerals, such as montmorillonite. The presence of expansive clay, this is an expansive clay minerals in soil, can cause an excessive swelling when the soil comes into contact with water. So shrinkage as well as swelling both will happen depending upon the moisture content. So swell potential or the volume change is defined as the ratio of increase in thickness to an initial thickness of the soil sample of a fixed dimensional size of the specimen. So the swelling potential is again, you can say, when the expansive soil obtain the moisture, they expand or swell up. Likewise, when expansive soil lose moisture, they begin to shrink since foundation walls are designed to support loads from the above rather than lateral sideway. The bearing expanding soil can cause us the foundation problems. It's a common thing. So swelling potential is very important for expansive soils. A number of clay minerals or those are also expansive soils. So cementite, bentonite, montmorillonite, beadleite, and vermiculite, atapulite, and non-trionite and chlorite are some of these soils which comes under such categories. Now, we'll go into the area of the field exploration, and that is also called as sometimes the soil exploration. So swell potentials, when you want to know, you should get the sample of the soil. So field exploration and soil explorations are essentially needed. Now, how do we do such field exploration, soil explorations? Now, let us go about by step to understand what is that. The field exploration or soil exploration, it has an introduction. How I can give an introduction, I will show you. Then method of investigation, method of boring, soil sampler and samplings, location and number of the pits and borings, penetrometer test, borehole logs, and geophysical methods. So these are all the field explorations normally you come across when you explore the soil or when you want to understand the soil characteristics. Now what is there in the introduction is, soil exploration is a part of site investigation. Site investigation in general deals with determining in general the suitability of the site for proposed constructions. When there is a proposed construction is there, normally some expert's opinion will be asked to go to the site and find out what is the conditions of the site. You call it as the site explorations. The site investigation, site explorations are slightly different. The site investigations, if a construction manager goes, then you'll be able to find out what is the resources available for the project, how the men and material availability, how far you can move the material, what is the expense of the material, how you can quote for the job. These things are comes under site investigation. Soil exploration is dedicated to the soil which is available at the part of the land. How the soil contains, what are the vegetation it has, how whether it is a loose material, solid material, at what depth what material is available. These are all very much required to design the foundation as well as to run the project. So when a site is handed over to you, you just have the sampling rig. You have to have an undisturbed sample. You should not disturb the subsoil as well as the ground surface soil as well as the underlying soil. Or nothing should be disturbed to get the real character of the soil. So you have the window samplers, ballast, GFOP surfing, then drainage structures, then drilling rigs, and cone penetration test. All those things done in the laboratory. Then sinkholes, then microgravity surveying, then drainage, gravity. Then there may be some structure, for example, ancient mines, working mines. Underneath the ground, some of the mines could have been abandoned, which have been functioning quite some time back, but at present it may not be in the live condition. Such things where the structures are being under the earth and it is in the abandoned conditions, what are the presence and how you handle this soil when you put a structure over and above that. Whether the uh, whether the abandoned mine can take any load or not, that we should be able to justify it. So attempt at understanding the subsurface conditions such as the soil and rock profile, geological feature of the region, position and variation of the groundwater table, physical property of the soil and rock, contamination if any, the general data of adjacent structures, hydrological data, topography, soil maps, and seismicity, etc. So these are all the subsurface conditions which you need to understand when you go for the soil explorations or field explorations. Soil rock profile, you have to identify, you have a method for it. Geological features of the region, you have to understand, and there are methods for understanding it. Positions and variation of the groundwater table, you have to have some mechanisms to find out where exactly the water table exists. Physical properties of the soil and rock, you have to take the test samples. Contaminations, if any, so you have to take the sampling waters and then test it in the laboratory. Then general data adjacent to the structure, hydrological data, topography data, and soil map, seismicity, etc. All those things one by one you need to understand when you go for the soil explorations. To determine the type of foundation, it requires for the proposed project at the site, the shallow foundation or a deep foundation you will arrive at depending on the bearing capacity of the soil. To make recommendations regarding the safe bearing capacity or pile load capacity, you need to know about the subsoil. So ultimately, it is the subsoil that provide the ultimate support to the structure. So the thorough investigation or in-depth understanding of the subsoil and the underlying soil on which the structure is located, all those things are very, very important to look upon that. So you decide about the foundation, what type of the foundation, either the deep foundation or a shallow foundation. It may be a shallow foundation, an isolated footing, or it may be a raft foundations. If the bearing capacity is good and column spacings are very nearer, the raft foundations may be very ideally suited for the structure. Or if it is a concentrated loads of heavy loads and your subsoil is having a very less bearing capacity, then you have to go for the deep foundations like pile foundations. That decision you need to take only if you have the field explorations and soil explorations. If it is not done, if you have some standard foundations, you just go and adopt at all the sites without understanding what exists at the underlying soil or what is the soil below the loose rock or something like that, then there could be a possibility of the collapse, what you see in this figure, a collapse of the very big roadways have come down. On the next side, you see the railway track is going on. In fact, the abutment, what it is retaining the earth, has collapsed very badly because the soil, what have been investigated during the site, you have done some, there are some protection works are also done in that. With all that, the soil heaving has taken place and it will cause us the damage to the railway tracks. It doesn't stop with that. You may be seeing that some railway track is stopped. No, no, it is not like that. If you look at, there is a very big tree is there, very big structure is there. You have some housings are there. When the soil undermines and wash away from that area, the bearing capacity of the soil is very much less because of the soil movement and the structure which is standing there, a person standing there or a very big standing there, all will slowly come down to the track. So it will take some time to come, but definitely it is going to come back. So it's a progressive collapse what you come across when some part of the soil fails and the other part of the structure, even though it retains, but if it is on the critical stage of the stresses, then the failure will be continuing. You call it as a progressive failure that can also be initiated because of the poor estimation of the soil capacity. Now, the leaning tower of Pisa and the sinkholes, these are all some of the aspects we will come across. The poor and the soil starts moves at the tower of Pisa and makes the tower to tilt more than uh, more than 2 to 3 degrees out of the plumb, and there are sinkholes are there where the sinkholes is because of the liquefaction of the soil. Liquefaction is the soil water table rises up and soil will be fully under submerged condition which do not carry any of the bearing capacity. It will be like a liquid or it will be like a flowing water and it will have the zero bearing capacity. If somebody goes and stands on that, he will simply sinking into the mud. And if any structure stands on that, it will be slowly swallowed up. You can see that sinkhole here where a tree is already gone, one structure is slowly going under the ground level. And that's how the sinkhole develops if the condition of the soil is not being properly investigated and if an aquifer zone is fully waterlogged, then such things can happen for the real structure. So soil exploration is a must for you to understand how to erect the structure. The three important aspects are planning, execution, report writing, or the soil exploration. There are different aspects for planning, execution, reporting in different aspects. So here, the planning is to minimize the cost of exploration and yet to give the reliable data. You cannot just spend a lot of money on the soil exploration, which is equal to some percentage of the cost of the project by itself. So a cost of the project, if it is somewhere around say 20 lakhs, then you may not be able to spend about say 10 lakhs for the soil explorations. So it has some percentage of the relations. You cannot just like that. So minimize the cost of the exploration. Then decide on quantity and quality depending on type, size, and importance of the project and whether investigation is primarily or detailed. There are some primary investigations, yeah, reconnaissance investigations are possible at the site, but there are some detailed investigations also very much required because the detailed investigation only will tell you the bearing capacity, water table locations, location of the weathered rock, location of the hot strata, location of the clay layers, drainage capacity of the clay layer. All those things will be done only if the detailed soil exploration is done. Any preliminary soil explorations will tell you what are the vegetations available on the ground, how the undulations of the ground, if there is any outcrop of the soil rock or if there is some igneous rock outcrops are there. Such investigations you can always tell because of the reconnaissance survey and in the preliminary investigations. But in-depth knowledge about the soil, you can get it only if you go for the detailed investigation of the soil exploration. So executions. The collection of the disturbed or undisturbed samples or subsurface strata from the field. Now, then, conducting in situ test of the subsurface material and obtaining the property directly or indirectly. Study of the groundwater condition and collection of the sample for chemical analysis. Then geophysical exploration if necessary, laboratory testing on samples. So collection of the samples, disturbed and undisturbed samples. If the samples are collected undisturbed, then you can get the real site condition value of the soil bearing capacities, soil penetration test capacity, and soil. You can keep that sample into your triaxial test to find the angle of internal friction phi, and similarly you can get the cohesion if you have the triaxial test or if you go for the UCC test, things like that. If the soil get disturbed, such test may not be possible. Then you may have to dry it up and then you have to go for the soil sieve analysis, liquid limit plastic limit. Such basic test only you can do if you have the disturbed samples. So undisturbed samples are very much valuable and very important, because it can straight away give you certain values which is very much required for the design of the foundations. So conducting in situ test, subsurface material obtaining property directly or indirectly. So these are all some of the tests you have to do during the soil exploration execution. Report writing. Description of the site condition. First you should write topographic features, hydraulic conditions, existing structure, etc. Supplemented by plans and drawings. So these are all the things when you do the preliminary investigation or the reconnaissance survey, these informations you can get it. But the description of the nature, the type of importance of the proposed constructions, you should know what is the constructions, what is the nature of the structure. Then the description of the field and lab test is carried out. After collecting the maybe a disturbed sample or undisturbed sample, you can go for the field and laboratory test to identify what are the physical characteristics of the soil. Analysis and discussion of the data collected. We have to analyze and then get it. Why you have to analyze? Because there may be some experimental error. You may be predicting something, not necessarily that has to be true, with some percentage of error can always be built into that. So preparation of the charts, tables, graphics, things like that, we got to do it. Then calculation performed, then recommendations you should go. The recommendation should always based on the analysis, discussion, collection of data, and description of the field and the lab test which are all being carried out. A complete site investigation will consist of 1. The primary work, collecting general information and already existing data such as the study of the geological, seismic map, etc. or at a near site. Study site history, if previously used as quarry, agricultural land, industrial unit, etc. Site reconnaissance, actual site inspections to judge the general suitability, decide exploration techniques, things like that. So, if you're really interested to go for the site investigation, collection of the already existing information is one aspect, then study of the site if previously used as the quarry, agriculture land, or what is that it is the what is the land use of that specific soil. Then information already existing such as geological. Then what is the next is the seismic map. Seismic map is very important. In which zone your site is belongs to. Whether it is zone 2, zone 3, up to zone 5, you have a classification in India. So if it is a zone 5, then a factor should be accommodated for the seismic effect on the building. If it is 2 or 3, then the intensity of the seismic effect on the building will be very much less, but still some small percentage of the reinforcement is required to account for the seismic uh, effect on the buildings. So the seismic map is required. On which seismic map is there any location of epicenter is already existing under the site? Epicenter, I just want to explain what is epicenter is the center of the location where the earthquake starts. So the earthquake always have a concentration point. You call it as an epicenter. So is there any previous history of location of the epicenter in the soil in the site has to be known earlier before you go for the real construction of the buildings. Then site reconnaissance, as I said earlier, you have to just watch what is the how you can see the actual site inspection to judge the general suitability, decide the exploration techniques. The site investigation will tell you, is there any water supply link is there? Is there any link of the roadway is there? Link of railway is there? Because men and material movement is very important for any projects. So all those things you will understand in the site reconnaissance itself. Exploration. The preliminary investigation says the explanatory boring or the shallow test pits, representative sampling, geophysical investigation, etc. Then detailed investigations are deep boreholes, extensive sampling, then in situ testing, lab testing, etc. They are the detailed investigation. They are very expensive and carefully it is done. Depth and spacing. In general, the depth of investigation should be such that any or all strata that are likely to experience the settlement or the failure due to loading. Spacing depends upon the degree of the variation of the surface topography and subsurface strata in the horizontal directions. So it was given by Alam Singh. He's a great author. He's an Indian author on soil mechanics. So it's a prediction. It's a fair judgment of the great authors. The spacing depends upon the degree of variation, things like that. So deep bore or a detailed investigation could be understood only by the deep bore holes and undisturbed samples you can collect. Other explanatory boring may be a shallow test pit or the representative sampling geographical investigations, etc. will give only the preliminary data about the soil. Methods of investigation. Test pits. It permits the visual inspection of subsurface condition in the natural state. Maximum depth is limited to 18 to 20 feet, especially usually for gravelly soil where the boreholes may be difficult. Sampling testing done on exposed surface. So it is done, the permit the visual inspection subsurface condition is a natural state you have to visually you should observe. What are all the vegetations available? Is there any roots are present in the subsoil? Is there any waterlogged area in the area? If nothing is available, you can make a trial pit or a test pit. The maximum depth can be 18 to 20 feet, which may be equal to 1 story height of the building. 1 to 2 story height of the building given 20 feet means. So to that extent, you can dig a pit and understand how the soil is there. It's an inspection pit, especially useful for gravelly soil where the boreholes may be difficult. So opening the surface and then understanding is very much useful if the now stratigraphy and then fields. The layers. The sandy soil. See, maybe for L1 layer, you can see that in the figure there is an L1, L2, L3. If you put a borehole or if you put an inspection chamber, what is shown in the figure and photograph, you can see L1, L2, L3 or sandy soil. And L5 is a loomy soil. L5 is located with a thick tire after L1, L2 and L3. Then L6 also loomy soil, but after that loomy soil you can put a dig pit, put a trial pit, and then say a decomposed bedrock is there or a weathered rock may not be there. Maybe a decomposed loomy soil with a decomposed or the very uh, bedrock or a loose bedrock may be available. So such type of the information you will get it when you put an inspection uh, site investigation and put a deep bore as well as the exposing surface of the soil. Methods of boring. You can have an auger boring, the simplest method of exploration and sampling, then power driven or the hand operated, or maximum depth may be 10 meters, it is equal to 30 feet, maybe 10 meters equal to 3-story building height. The suitable in all soils above the ground water table, but only in the cohesive soil below ground water table is also required. Then hollow stem auger used for sampling or conducting the standard penetration test, SPT test. Auger boring is the simplest method of exploring and sampling. And power driven or hand operated is another method of boring. The maximum depth is 10 meters, suitable in all soils above groundwater table. But only if it is a cohesive soil below the groundwater table it is possible. Otherwise, if it is a sandy soil or a gravelly soil, you may not be able to do it because the water table have an influence on the soil and there could be a possibility of collapse of the soil is always there. So in cohesive soil, because of the cohesion, it can retain the borehole below the groundwater table. Also, you can explore the soil by means of the boring. There are stem auger boring, there are power auger boring. We'll see one by one what is what. There. Power driven augers, the stem boring is you can have the petals, then you can insert into the hole, then you go on rotate it. When you rotate it, the screw goes on entered into the soil and then it goes and then scoop out the soil and takes out. You can put an auger or you can scoop out the soil by it's something like a drilling. Just like your drilling machine, it's a very big size for your rock drill, or it is very big size for your soil drilling. That's all. It may be hand operated as in the case of figure 2. In figure 1, you can see an auger bore well and hand operated and it's a machine operated. It is operated on the compressor tools. It is one of the compressor tool where high pressure is used for auger drilling as well as some motorized mechanism are also used for auger drilling. You can see an auger boring here. You can see a manual auger boring also here. So wash boring. A casing is driven with a drop hammer and a hollow drill rock with a chopping bit is inserted inside the casing. Soil is loosened and removed from the borehole using the water or a drilling mud jet under the pressure. So the water is jetted in the hole through the bottom of a wash pipe and leaves the borehole hole along with the loose soil from the annual space between the hole and the wash pipe. The water reaches the ground level where the soil is suspension is allowed to settle the mud and recirculated. That's how the method of boring. Wash boring, you just insert a sleeve into that and then you apply a pressure of the air mixed with water and the soil gets pumped out along with the moisture and then they are collected and then they are dried and then they are being filtered very carefully and then soil is renovated or recovered, then it is tested in the laboratory test. The another example of wash boring is called mud rotary drilling. Mud rotary drilling is an hollow drill rods with a drill bit is rotated into the soil and drilling mud is continuously pumped into the hole. The bit grinds the soil and return flow brings the cutting to the surface. So you just go on drill it and there are the return flow is also possible. It goes on replace the drilled soil also. Core drilling is used for obtaining the rock cores. Core drilling is a machine wherein a cylindrical surface is go on rotate at the high speed and when you just keep it on the surface of the rock, this rotating teeth will go on cut and inserted into the rock slowly with a small pressure on that. So that core drilling is a pipe drilling which pipe go on drills the rock and then penetrated. When you remove the pipe, whatever the material occupied inside the pipe is taken out, which is called as a core. A core barrel is fitted with a drill bit is attached to the hollow drill rods. It is called the core barrel. The instead of drill bit, a core barrel is fixed to collect the samples. So diamond core is there, calyx or the short core drilling, different core drilling machines are there. And that is schematic of the wash boring. Wash boring is you insert the sealing in that and then pump the water at the high pressure. You can see a tray is kept there. All the mud and samples will be collected there. It is carefully filtered. Only water is filtered. Even the loose material to the variation of the graded materials are also being collected and they are dried and sent for the soil mechanics laboratory for testing. And this is also coal drilling equipment where you can see a drilling equipment is sent into that. You can see the core breaker, the core goes inside the drilling machine and then core drilling and then it is taken out and the core inside is tapped out and then that core undisturbed sample can be tested there. It's a diamond drill bit. In case of the rock, you use the tricone drill bit, which is having a high degree of hardness, and then it just hit it and then go on drill it, and it penetrate into the rock to see what are all the available material under the rock. As such, the rock is disturbed, but anyway, it can penetrate it into the rock to see are there any rock fissure is there, or any water table coming into that, or any loose material coming after the rock, or what you are investigating may be a boulder. All those things you will get the information because of the diamond drill bit. So the percussion drilling is another way of doing it, grinding the soil by repeated lifting and dropping. There in diamond drilling, you go on drill it, but in percussion drilling, you drop the drill bit and then with a high pressure you damage the rock surface, then you lift, then you go on grind it. It's another method of drilling. That's so water is added to form the slurry of cutting. The slurry is pumped out. Slurry is removed by the bailers of the pump. In general, a machine used to drill the hole is called the drill rig. It's generally power driven, but maybe a hand driven. A winch is provided to raise and lower the drilling tools into the holes. Okay, that's how the percussion drilling is done. Method of investigation, probing or sounding method, drive a pipe or the rod into the soil, measure the resistance offered by the soil, example CPT, SPT, things like that. Then geophysical method or the seismic refraction method, electrical resistivity method, they are also methods for the soil investigations. So probing or the sound method is maybe an ultrasonic scanning or some other scannings, or you can have any X-ray scanning. You can have the sound scanning, or maybe ultrasonic, or maybe a sound. You just send the uh, pulses of the sound. You get back that sound pulses, and then you evaluate what are the things available. It has to be calibrated and then evaluated. So man-made environment. So how do you spoil the site? Because of the solids and because of the liquid. Agricultural waste, you spoil the soil. Human and animal waste, you spoil the soil. Industrial waste, you spoil the soil. Mines waste and pyrites and nuclear waste, construction effect, blasting, dewatering, debris. All those things, the methods of spoiling the soil. See, soil, you always think it is a dumping ground. Soil is a, in fact, it is a mother of holding the full earth. In fact, the soil should be preserved, and you should take precautions to preserve the soils, because soil you never consider, and we ignore the soil. We use it as a dumping yard, use it as a garbage yard, and use all waste material on that. It should not be done like that. It should be regarded, and that's how you should respond to the soils. Soil response to environment, soil structure, uh, then pore fluid character, soil heat, soil chemical, bacteria, root, electrical, liquid, and water, things like that. So these are all the things environment-wise you can protect the soil. You avoid chemicals entering into soil, you avoid bacteria, you avoid maybe your fertilizer entering into the soil will spoil the soil character. Then you just blast some nuclear blast inside the earth, and you generate a lot of heat in that, and you spoil the soil characteristics. So poor fluid characters, all your waste are being penetrated into the underground soil, and then you spoil the soil very badly. Now, the basic concept of analysis, most geotechnical project occurs in nature, the long-term phenomenon. Soil is more sensitive and susceptible to environment than any other construction material, but you ignore very badly. The loading may greatly affect the soil properties, but not only the parameter to be considered. Thinking of other factors or heat, moisture, wet, dry, pollution, intrusion, things like that. So classical soil mechanics, some of the flaws. So when the soil is taken into that, then you just do go for the analysis by the classical soil mechanics. So you do the void ratio porosity indicator of soil deformation. Water in the soil mass is mainly a gravity water. The need to consider the environmental water. The constitutive models are arbitrarily chosen. Stress-strain relations are not being well exploited in the old soil classic mechanics. So soil classification controlling parameters are maybe soil consistency, then maybe the moisture content, liquid limit, plasticity index may be present in the scenario, and that is how you do it in the parameter study. But not necessarily that is the real value for to give all the characteristics of the soil. So the proposed scenario is the parameters. What you should understand is percentage of passing through 20 micron sieve, specific surface, pH in pore fluid, ion exchange capacity. You should supply some electricity and then see how the ion exchange capacity, absorption and adsorption test, thermal properties, conductivity, diffusivity, specific heat. dielectric constant, electrical properties. All those things you should understand when you go for the soil controlling parameters. So you should establish so environmental and geomechanical laboratory along with the soil laboratory. Then we should understand what all the chemical person. Previously liquid limit, plastic limits are all old soil mechanics. Now you go deeper into that. You take it as a, just like you analyze a salt in your chemical laboratory, you analyze the soil now with a high level of the accuracy and high level of the advantages, because lot of material advantages, instrument advantages, everything has come up. So now the soil laboratory is changed as environmental geomechanical laboratories. So all those things we should use it for soil explorations. So thank you for listening. Thanks one and all. So that's how the soil exploration is done. Thanks for joining with me. We'll see you in the next lecture. Thank you.